Go ahead and let's take a peek at this problem. So I'm working with some proprietary alloys we discussed in the last exam, and I am looking at the electrochemical properties of the materials in a solution that is basically a sulfuric acid at 100 degrees K. My employees gave me a list of voltages below. So we are not at STP conditions. So we can't use our kind of standard table values to kind of calculate this. So we need to look at what is the potential of the cell to tell us where the electrons are flowing. So if we remember back on our to our notes, so in general, if our electrons, let's go ahead all the way back into lecture 8. So if our electrons are flowing from our positive terminal, so our cathode, if they're flowing from our, if they're flowing from our negative terminal to the positive terminal, that's a positive voltage. So if they're flowing from negative to our positive terminal and we measure a positive voltage, then that's where the electrons are flowing. So if the electrons are flowing from our negative terminal, positive voltage, positive to negative, then it's a negative voltage. So with that in mind, let's go ahead and look at this. Let's see where our electrons are flowing. So here, electrons are flowing from negative to positive. Here, electrons are flowing from positive to negative. Here, electrons are flowing from negative to positive. Here, electrons are flowing from here to here, and then here to here. So, which material is the anode and cathode? We know that the true cathode material will gain electrons, and the anode will lose electrons. So we see here, I'm just going to call this my anode. So my anode material is the one that is giving away electrons. So we said that electrons are flowing from here, electrons are flowing from here, electrons are flowing from here, and then here and here. And then my cathode material here will just be this, we're gaining the electrons. So, and again, that makes sense from our, let's just go, let me open up our, we have a beautiful PowerPoint about corrosion. So we know that the true cathode material will exactly reduce, we're gaining the electrons. So we've got that. Again, we know that cathodes also gain, that's also a reduction. So we know that as well. Which will corrode. The anode is the material that is going to corrode. So the anode corrodes, and then the anode also undergoes oxidation, the redox reaction. Rank the relatively electronegativities of PT, Z, Y, Mg, and X in order of in increasing order of electronegativity. So we know high electronegativity means it really wants to grab those electrons. So we can see based on this voltage, Y is the lowest, and then Z, because, or excuse me, not Z, PT. Because Y and PT are both giving up, those electrons are leaving. So it's giving away those electrons. So those are the two lowest. And we say Y just because looking at this voltage value here. So then we need to look at what's grabbing the electrons. So then it would be Z, again, based on the values, and then Mg. There we go. Then it says, finally, calculate E naught of the cell at standard conditions for the known materials versus zinc, i.e. PT and Mg. So we need to recalculate. So for these known materials, what is my E naught? So for this guy and then for this guy. So let's go ahead and let's take a peek at it. So let's go ahead and pull up our, actually we have in our lecture notes. So we need basically the E naught of our, so PT is around, let's just kind of pull up our Mathematica right here. So my PT is equal to 1.2. What else? PT, I need zinc. What's my zinc? My zinc, on the other hand, is minus 0.763, 0.763. And then I think I need Mg, but I want to double check. Mg, yep. So my Mg is equal to minus 2.363. That's 2.363. All right. So I have got those values. Let's go back to our kind of page here. So let's kind of write out and let's draw out this first, just to kind of get a sense. So right here, we have as our positive terminal, so positive is Zn, and then our negative terminal, and you might be asked to write these full cell reactions as well, is PT. So we know that in general, this should be our cathode material, so it should be flowing from here to here in general. So we should know that the reaction going on this side of the cell should be basically 2E plus Zn 2 plus goes to Zn. And here it should be Pt goes to Pt plus 2 electrons. And then, let's put that right here. So my full cell reaction would be basically Pt plus my Zn 2 plus goes to, this should be Pt 2 plus goes to Pt 2 plus Zn. So that should be my full cell reaction. So if that's the case, I need to do my E naught is the cathode minus the anode. So it'd be my Zn minus my Pt. It's a negative value. So what's the real cathode and anode material? What will, really it should be Pt minus Zn. But again, that's the value for this experiment. So that's not the real cathode material and the anode material. So you can do the same exact procedure here. So the other materials would be Zn and Mg. So Zn minus Mg. Oh, what do you know? But again, that makes sense from our electronegativities, right? It should grab the electrons from zinc. So that's it. So not too bad of a problem. We just need to see where the electrons flow, what's electroplating, what's oxidation, what's kind of happening in here, and then, yeah, we move on from it there. So remember these basics, remember how to write those full cell and half cell reactions, and then you'll be just fine on the exam. All right, next time we're going to get into polymers. So I'll see you next video. Thanks.